Hello everyone, that is going to be our test 2 practice problem video. As you know, test 2 covers module 3 and 4. So the expectation is that you have all the homework and quiz, all the homework and quizzes for these 2 modules done by the day of the tests for your class, as well as the test 2 practice problem, module 2 and module 4, module 3 and module 4 in MyLab Math. And you know, when you complete this assignment, it gives you 10 out of 100 on your test, on test 2 for this one. So obviously some of you will do that, and this is the expectation, that if you do that, you will get your full credit for your test. You will not even need the extra credit that is being promised to you. However, being prudent, if you do it, you get yourself covered if you make some mistakes on your test, despite you studied and get everything, because mathematics, you cannot be 100% sure. So you get yourself covered. So you understand the plan? Let's get started. Number 1, simplify the radical. And since we have variables, all the variables for all the problems in this test practice problems will be considered as positive. Okay, so let's see. This problem here, we're gonna start it with, you know, we're gonna solve separately cube root of 125 times cube root of x to the 9th power. And we're gonna try to solve 125's cube root, right? Cube root of 125 on the side. We know that to solve your radical manually, you have to break this number down into prime factors only. So the end of your factor tree should only be prime numbers. So if we want to start by the smallest prime number that goes into 125, we know for sure that 5 is a number, a prime number that is a factor of 125, but we want to check to make sure that 2 doesn't go, because it doesn't end with a even number. 3 doesn't go, because when you do 1 plus 3 plus 5, we add the digits of this number. It doesn't add to a number that is a multiple of 3. That's how you check for whether a number is a multiple of 3 or not. You add the digits. If the result is a multiple of 3, then this number itself is also a multiple of 3. So 125 is not a multiple of 3, because 8 is not a multiple of 3 when you add all the digits of this number. So 4 is not, Obviously, if 2 is not, 4 will not be. And then 5 would be the next stop. 5 times what equals 125. 5 times 25 is what equals 125. 25 is not a prime number, so we want to break it down more. So 25 is 5 times 5. Then index is 3. So we should make groups of identical factors, but each group should include 5. Sorry. Each group should include 3 elements because the index is 3. We have one group only because we had only 5 as prime factors. So we can pull out one of them because we made a group of 3. And then this will be the cube root of 125. So that equals 5 times x to the power 9/3. So if you remember what we did in class, is that when you're solving the exponent, the radical of a variable with exponent, you always divide the exponent of the variable by the index. So that's what I did. Take the 9, the exponent of the variable, divided by 3, that was the index. So then simplify 5 x to the power 3, that is the answer for cube root of 125 x to the 9th power. Next problem. We're going to go a little faster. Separate square root of 25 times square root of a to the 8th power times square root of b to the 36th power. And we don't want to forget that any answer that doesn't have any type of that has no type of work to support it will not receive a credit. Remember that. So square root of 25 is 5. Square root of a to the 8th power is 8. A to the power 8 divided by 2. And then square root of b to the 36th power is b to the power 36 divided by 2. And then moving forward, 5a to the 4th, b to the 18th power. That's it. The next, since we have a negative sign, and whenever you see a negative sign inside of the radical, you want to check to see whether you have an odd or an even exponent. In this case, we have an even. If it's an odd and they don't tell you to continue to solve using the I property, all of you should now know what the I is, but I want to go over it to make sure that everyone who's watching this video understands what the I property. I is for imaginary number. Imaginary number is I equals the square root of -1, and that is the only number that you will encounter that is equal to a square root of a negative number, I, imaginary number. And then also I squared equals -1. So whenever you see I squared, you should always replace it by -1. So that said, we can move the negative sign to the outside. Negative square root of, I mean, not even square root, negative cube root. If it was square root, then we would not have to solve it. So that's negative cube root of 64x to the 9th y to the 12th equals negative cube root of 64 times cube root of x to the 9th times cube root of y to the 12th power. And then we should find the number to multiply itself 3 times and equal 64. You can break it down by 2 because 2 goes in it. So that's 2 times 32, 2 times 16, 2 times 8, 2 times 4, and 2 times 2. Make groups of 3. 1 goes out. Another group of 3. 1 goes out. And when you multiply the outside numbers, it gives me 4. The negative sign drags down, so 2 times x to the power 9 divided by 3 times x to the power 12 divided by 3. Answer is 2 times x third to the 3rd power, y to the 4th power. The next problem is the same scenario. We want to do it. So that's the negative sign out. 5th root of 243 times 5th root of x to the 10th times 5th root of y to the 5th. And then 243. We want to see what number that will be the first or the smallest prime number to be a factor of 243. It looks like 3 is going to be 2 plus 6. 2 plus 4 is 6, and 6 plus 3 is 9. So 9 is a multiple of 3. Then 243 is also a multiple of 3. So let's start with 3. So now we would say, what times 3 equals 243? So 243 divided by 3 is 81. And then we continue 3 again. 81 is a multiple of 3. 27 times 3 equals 81. 27, we also can break it down to 3 times 9. And then 9 is 3 times 3. The index is 5. That means we are making groups of 5. We only have 5 3s, so we can only make one group. One element goes out from the group. And then now we have that. Negative sign, we drag it down. -3, -3. And then that was 3 was the cube root, the 5th root of 243. So now this one is x to the power 10 divided by 5. And this one is y 5 to the power 5 divided by 5. And then we can simplify now to have the final answer. Negative 3x to the second, 10 divided by 5 is 2. And then y power 1, you don't even have to put it. So that's negative 3x to the second power y, negative 3x to the second power y. Next problem. I have to simplify the radical of 64 ninths. Well, the first thing, if you are in class, you would know that whenever you see fraction, the best strategy is to separate the radical. Give the numerator and denominator their own radical. So let's do that. Square root of 64 over square root of 9. Easy now, we know all of them. 64 square, what multiplies itself 2 times equals 64. Everyone knows that is 8. What multiplies itself 2 times to give me 9, everyone knows that is 3. So 8 over 3 is the radical of 64 ninths. Here is a word problem, and then one of these will be on the test. The muscular formula for calculating adult body surface area is B equals the square root of the fraction HW over 3,131. Well, B is the individual's body surface area in square meters. H is the individual's height in inches. And W is the individual's weight in pounds. Find the body surface area of an individual who is 71 inches tall. H equals 71, and who weighs 136 pounds. So that is W equals 136 pounds. So we have H, we have W. These are the only variables in the equation. And we want B. Well, B would be, and remember, B is in square surface area in square meters. Square meters. So B equals the square root of W, H times W, right? So H is 71 times W, that is 136 over 3,131. We're going to solve the expression inside of the radical, then take the radical, take the square root. Well, do not round before you get your final answer. So let's start. 71 times 136, that equals 9,656. So B equals the square root, because I have not solved it yet. That's why I keep it. 9,656 over 3,131. Now is when I'm gonna perform the division inside of the radical. I'm not solving the radical yet, so then I keep it. Then I divide 9,656 by 3,131. I find, and I'm going to write the entire expression. Well, if you are tired of doing it, I'm showing you that I do it. Now, I do it to show you how to do it. If you don't do it for me, you have no credit. So the answer I found was 3.0839 98 722. And then to find the final answer, B equals, I'm going to round after I take the square root of this number. The square root of this answer is 1.756. I round to the two decimal places. So 76756. 56, I round to 76. So remember, I said I find 1.7756 and then 13175. So I don't care about these other numbers. Round to the nearest number, that is 1.576. And then square meters. Now, next problem, number 7. They say, use the radical notation to write the expression. Simplify if possible. Assume variables are positive or non-negative numbers. So that's it. What I want to emphasize on is that whenever you see an expression with rational exponent, you need to identify what is coefficient, what is base of your exponent, and what is the exponent. The rational exponent indicates that you have a radical where the index is the denominator and the top number of the exponent fraction is the exponent of the entire expression or the exponent of the radicand. It does not make a difference whether you keep the exponent for the entire expression or you keep the exponent with the radical. But my advice is that you keep the exponent over the entire expression, not including the coefficient. Only the expression that is the radical you need to keep in exponent. The exponent that is the top of the radical. That said, this expression 4 is a coefficient, so it's not going to go inside of the radical. The base of the exponent is the only thing that goes inside. So that's it. 4 on the outside, and then the 1/2 means that I have an index 2, so square root of m. And one exponent, you don't even have to write it. So 4m to the 1/2 power is equivalent to 4 square root of m. So if you understood the last one, this one should be easy. If you want to stop the video to try and see what I do after, that would be the best strategy. But let's go over it. So you see how everything put inside of a pair of parentheses to indicate that the 1/2 power is a power for 49x to the 8th power. That means 49x to the 8th power goes inside of a square root because the index is 2. So 49x to the 8th. And then you know how to solve. We separate square root of 49 times square root of x to the 8th. And then we all know square root of 49 is asking me to find a number that multiplies itself 2 times to get 49, that is 7. And then times x to the power 8 divided by the index of this expression, of the radical, 2. And then 7x to the 4th is the answer. Next problem. You understand the process now. So everything in parentheses is base of the exponent, 1/3. That means all the thing in parentheses will go inside of this radical, and then the index is 3. And you know also that the index being odd, I am allowed to move the negative sign out and then have 27 as the radical that I need to solve. Cube root of 27 as the radical that I need to solve. What is the number that multiplies itself 3 times? 3 is being the index to get 27. All of you, stop the video, think, and get the answer is -3. The negative is not negative cube root of 27. Negative was already outside. Also, -3 is a number to multiply by itself 3 times to get -27. So that's a cube root of -27, -3. In this case, we do not have a pair of parentheses that will tell me that the whole thing goes inside of the radical. So the negative sign will slip outside. Gotta be careful with that, because if you don't pay attention, you keep your negative sign inside, it will give you something that is not a real number. And as you can see, we don't talk about I here. I'm not taking any answer that involves I if I is not being asked to use. So everyone knows what the square root of 16 is, right? What is a number that multiplies itself 2 times to get 16? All of you know that is 4, but with the negative sign outside makes it -4. Right? With positive exponents, simplify if possible. Well, one thing we didn't say is that you're going to have to work with this number until you get radicals, because this exponent fraction is nothing but a radical. You have to remember that. So, but let's start with the negative exponent. The negative exponent is this property that we went over in class, right? So if I have a exponent negative, n is 1 over. So the whole thing, it goes under 1, right? So that's a exponent 1. And as you can see, the only thing that I changed to put under 1 is the negative sign that is the exponent. I used to see some of you, if you have a negative sign in front of the number like this, you change both of them. Nope. Something like this would be as 1 over negative a to the power n, because the transformation 1 over does not change the sign of the coefficient. It only changes the sign of the exponent. If it was positive, it changes to negative. If it was negative, changes into positive. So that said, this is going to be 1 over, if you want to stop and think, great. So that's 729 to the power. You know, this thing is too high. I'm going to put it lower. And then exponent is 4/3. All my work is in denominator because it's just 1 in numerator. So let me do the work in denominator. I want to see this thing with a fraction exponent into radical form. So that's going to be 1 over radical of, what's the index? Stop and answer the question for yourself. What's the index? 3, 7 for 29. Like I said, I like when the power goes on the outside of the whole expression, radical expression. So that's it. And then I'm going to solve cube root of 729. 729. I know obviously none of you would know this first. So that's why you have to know how to break down your number, factor your number that is inside, and make groups of numbers, identical numbers. And inside of each group should include this number of elements. 3, the index. 7 plus 2 is 9. 9 plus 9 is 18. So 18 is a multiple of 3. So 3 is a factor of 729. What? So I'm going to put it here. 729. I start with 3. Divide 729 by 3. It gives me 243. Then I go down. Divide by 3 again. 81. And then keep going. 3 times 27. 3 times 9. 3 times 3. Make groups of 3 3s here. 1 goes out to be part of the radical solution. And then another group, another 3 goes out. Multiply the two 3s. Inside of the parentheses, I will get 1 over 3 times 3, 9 to the power 4. And then calculate 9 to the power 4, which is 9 times 9 times 9 times 9. 9 to the power 4 equals 6,000. 1 over 6,561 is the answer for this problem. 1 over that. That's a number almost close to 0. So it says use the properties of exponents to simplify the expression. Write with positive exponent, assume that all variables represent positive real number. So here, a exponent n times a, same base, exponent p equals a exponent n plus p. Okay? Well, whether n, p, or negative fraction, it does not matter. All you know is that if I have the same base, I can add the exponents or subtract. Whether it's fraction or not fraction, that is not your problem. You applied your rule. So that equals x in the power negative 5/3 plus 8/3. And then, since we already have a common denominator, 3, negative 5 plus 8 with one fraction now. And then x to the power negative 5 plus 8 is 3/3. Then that takes me to 1 power 1. Power 1, you don't have to write it. So my answer is x. Well, when you divide, the only thing that changes is as I have the same base, n over p, you write it as one base, and then you subtract the exponents. So n minus p, it's always the exponent in numerator minus the exponent in denominator, but you have to have the same base. We have the same base here. So that equals y to the power 1/11 minus 1/22. You cannot add fractions if you do not have the same denominator. So that said, what do you multiply by to get 22 in denominator for the first fraction? That's 2. And then that takes me to y to the power 2/22 minus 1/22. Common denominator is 22. Y to the power 22, 2 minus 1 in numerator. Then finally, y to the power 1/22 is the answer. This problem here, first thing I want to do, you saw that I can move my negative sign when it's just one term that has the negative sign in the denominator. I can move it to the front of the fraction here. And then now that makes life easier for me to perform, and then know that the result will be affected by this negative sign here. So b to the power 2/3 times b to the power 2/3. I can write it as one base because the base is common. So that's 2/3 plus another 2/3 over b to the power 1/3. The negative sign goes up in front of the fraction. It doesn't change the process. So that equals, I'm not working with the denominator yet, so that I can keep it. And then that's b to the power 4/3. And then next side. Now I have one base on top with an exponent, one base in denominator as an exponent. I can write it as one base, and then the top fraction minus the bottom. And then b now becomes 1 denominator 3, 4 minus 1 is also 3. So that's b to the power 3 to the 3 over 3. 3 over 3 is 1. So my answer is b to the first power, or 1. So that's just it. What would you do here? Stop it and then try. First, we separate the radical, 7 square root of 7 over square root of 81. That equals 7 is not a perfect square, and it's a prime number, no factor that is a perfect square except for 1 that goes into 7. So I'm going to write this just like it is. And then the bar. Square root of 81, is 81 a perfect square? Stop the video and try to think. Yes, it is. What multiplies itself 2 times to give me 81? Answer is 9. So 9. And then that's it. Simplify this. Go ahead and 162. Break it down. 2 goes into it because it ends with an even number. Start with 2. Divide 162 by 281. And then do it again. But this time by 3, because 2 doesn't go into 81. So 3 times 27. 3 again times 9. 3 times 3. And then we make one group of 2 elements. Oh, wait, it's a 3. So we would make one group of 3, and anything that we could not make a group of will multiply and stay inside of the radical. This one and this one, we multiply them, and then it gives me 6. This 3 goes on the outside, and then 2 times 3 is 6. And then we're not gonna forget that it was a cube root that we were looking for. So if you don't put the index, it's going to be automatically a square root. So that's the answer. All right, let's see for the next problem. You have 2 ways you can do it. I'm gonna do it the easy way. This one was the hard way. You break it all the way down. But if you want to go fast, you think of one perfect square, and it should be the largest perfect square that goes into the number, and then a number that is eventually another number that is not a perfect square. I mean, 45 is easy to find because we know 9 is a perfect square. We're not going to forget that 3 multiplies the whole thing. And then 5. If I take the square root of this, I can't take the square root of 3 because 3 was not inside. But the 9 times 5 is 45, and 45 was the radicand. You want to take the square root of both, otherwise it's not going to be resulted to what you had prior to your process. So we want to keep the same thing. So that's 3 times square root of 9 is also 3. And this is not, 5 is not a perfect square. I just copy down the square root of 5. That is 9. So 9 square root of 5 is the answer for my radical. So 9 square root of 5. Okay? 9 square root of 5. That's the easy way, and the hard way is just like this. You break down until you get and pull out. How about this one here? There's a problem here, right? The index, I don't see it. That means it's 2. But 9 doesn't go. 9 is a number that 2 doesn't go into evenly. That means I'm going to think of one thing. Two things. First, my answer will include a radical, because whenever the exponent is not a multiple of the index, your answer will always include a radical part in it. So the variable will be separated into a power of the number of times the index goes into the exponent on the outside, and then a part where the variable will take the exponent of the remainder of this division, but that goes on the inside. But before we do that, let's separate this. So that is the square root of 49 times the square root of x to the power 9. If you divide 9 by 2, what would you get? Or how many times you think that 2 goes into 9 evenly? Your answer must be 4. 2 goes into 9 4 times evenly, and there is a remainder that is 1. So this is easy to find, because 2 times 4 is 8 plus 1. So 2 goes into 9 4 times. So this one is easy. So that's 7 x to the power 4, the number of times 2 goes into 9. And then the radical stays. The remainder is the power of the inside part of the variable. So that's this for that's why I said that you're going to have the radical stays in your answer. If it was just 8, then it would be, if it was just power 8, then you would say just 7x to the 4th. But because it's 9 and 2 doesn't go evenly into 9, then you got the remainder power inside. Same thing will happen here. Separate cube root of 108 times cube root of y to the 8. 108. Start with 2, because whenever 2 goes, I want to use 2, the smallest. And then 108 divided by 2 is 54. Divide by 2 again, 27. 27 doesn't have a factor 2, so that's 3 times 9, and then 3 times 3. Cube root, so cube root, so that's going to be a group of 3 threes. 3 goes out. And then 4 will remain inside, because we could not make a group of 3 2s. remain inside. And then so I can create my radical 3. Oh, not yet, because we want to make sure the very part of the variable that goes outside goes outside. Now, how many times the index 3 goes into 8 evenly? Your answer is 2. So that's x to the second. And then how many times, what's the remainder? Your answer is 2. So that, oh, I said x, that should be y. I'm sorry. So that is y, and then y2 also goes inside. So 3y squared, cube root of y squared. So these two, oh, sorry, 4 cube root of. These two stay inside. So that's 4 stay inside. Stays inside. So that's going to be 4y squared. Okay. So number 20, we are trying to solve this. You see, you remember in some cases when we have the radical, one radical for a fraction, we separated it, right? If you can recall. In this case, I think having the radical ones for the fraction can help solving the problem. Well, I mean, I'm not saying it is the only solution. If you remember in class, we did it both ways, but this one, I'm going to solve it by transforming the radical into one radical and then the fraction as x to the 9th in numerator, y to the 7, and then xy. Now, if you want to solve it the other way, you are free to do so. And I'm going to use the difference of power for each variable here. Keep the radical ones. X 9 minus 1 is 8. And then y 7 minus 1 is 6. And then since we have an even, we have even exponents and the index is 2, then we can just divide by the exponent by the index and have x to the power 4, y to the power 3, and that's it. So we have 75, 50, and 27, right? We can, you have two ways you can do that, right? 75 can be written as the product of a perfect square and a number that's not. Same thing for all of the other numbers, 50 and 27. So let me do that. That is 3 times 25. I want to put the 25 first. 25 times 2 and 9 times 3. The square root of this will be the square root of the product of the square root of these two numbers. Same thing. Square root of 50 is the product of the square root of these two numbers. Square root of 27 is the product of the square root of these two numbers. Square root of 25 is 5, so 5 square root of 3. Square root of 25 also 5, so that is 5 square root of 2, and square root of 27 will be 3. Square root of 9 is 3, so 3 square root of 3. Then bring them back into this problem. This is just that, right? So that's 4 times this. This is just that. So that is 3 times this. And this one has no coefficient, so that's going to be 20 square root of 3 minus 3 times 5. 15 square root of 2, and then plus 3 square root of 3. Like radical, we saw that in class, right? So like radical, you can add the coefficient and keep the radical just like it is. These two are like. So then that will take me to 20 plus 3. Do not touch the inside of the radical and do not touch the index when you're adding. So that is 23 minus 23 square root of 3 minus 15 square root of 2, because we can't combine these two as being two different radicand. So that's gonna be my answer. How about this next problem? This next problem, it's a cube root, and then 24, right? That's 2 times 12. 12 is 2 times 6. 6 is 2 times 3. Cube root, so I'm gonna make a group of 3, and no more group can be made, and these two will multiply and stay inside. So what? In the x, you see the power 1 smaller than 3. We can't move it, so it's going to stay inside as well. So 6 and x stays inside for the first term, but 2 goes out, because we could make a group of 2 2's or 3 2's, which will send 1 out. So 2 cube root of 6 and then x minus, we're gonna work with the second term, second radical. That is, we know x is going to stay inside. That's for sure, because the power of x is smaller than the index 3. But I want to work with 192 now to see what we can get from that, right? So let's see. 2 is okay. So divide 192 by 2. 96. Do it again with 2. 48. Do it again with 2. 24. Do it again with 2. 12. Do it again with 2. That's 6. and then do it again, 2, 3. Index is 3, so I'm gonna make groups of 3. I got 1 out and another 3, 2 factors, another 1 out, multiply them, no more groups, so that's 4, right? And then there's a 3 that stays inside, so that's what I get inside here. 3. Let me see again. Let me see. 2 divided by 196, 92 divided by 2, 96, divide again by 2, 48, divide again by 2, 24, divide again by 2, 12, and then go on. I'm trying to see what happens here because we would not be able to combine if it's not that. Let me see if number 22 okay. So did we, I think we made a mistake in 24. Let me see here. 24. Oh, I grouped them wrongly. Because you see how I used the 2 from 24, the 2 from 24 as a 2, but it wasn't, right? So I'm sorry about that. We're gonna have to regroup this. And it happens, right? It happens. And I show you that how careful you should be when you are doing this. So that's what I need to do here. 2 2s and 1 goes out, 2, and then 3 stays inside instead of 6. 3 stays inside. And then now we get what we want, right? That. So let me recap on that. 24 divide by 2. 2 goes in it. You want to start with the smallest, right? I mean, I'm not imposing that, but that's the best way for you to not making any mistake. Okay, so 24, 2 goes into it, and 2 would be the smallest prime number to go into a number. So divide by 2, 24 divided by 2 is 12, 12 divided by 2 is 6, 6 divided by 2 is 3. So index is 3. Make a group of 3, right? Put 1 out, 2 out, and then that's a 2 that goes out here. And then inside will be 3 and the x, because 3 we could not group anything with x with 3. It stays inside. And then the x, the power is 1 smaller than 3. So the x stays inside. And then we take the 192, break it down, find 2 groups of 2s. 1 goes out from each, multiply them, and then we get 4 on the outside. 3 did not group, get it inside, and then the x, power smaller than the index, stays inside. Okay? And then now we have like radical. That was the problem, actually. The fact that they want me to do that, I wasn't sure that they expected me not to have, like radical, so I can combine. Now I can combine. So I can have 2 minus 4, that's negative 2. And then radical, don't change when you combine, index stays the same, and then 3x. That's your answer. Okay, so let's move on to next. This, we've done one problem like this already, almost the same, right? So we want to do it here too, to make sure that you guys have enough practice to pass this test. You get that part. You're not going to fail this one, right? Yes, we'll get that. 75 75, 20, and then 27. Most of them already solved. 25 times 3 and take the square root. 4 times 5 and take the square root. And then 9 times 3, take the square root. Okay, that's 5 square root of 3. That is 2 square root of 5. And that is 3 square root of 5. And then this is only that. So we got 9 times 5 square root of 3 minus. This is only that, right? So that's negative 5 times 2 square root of 5. Let's shrink this. And then we have negative 7 times 3 square root of 5. And then we can multiply and simplify. So that's 45 square root of 3 minus 10 square root of 5 minus 21 square root of 5, right? Then we got 45 minus 10. Wait, we can do that? Sorry. Because 45, these two radical are not like, but these two are like. So we will combine 45 and 21, negative 21. 45 minus 21 is 24. So we got 24 square root of 24 square root of 3 minus 10 square root of 5. Okay. Let's advance in this. We're almost there. Let's FOIL for this one. I mean, FOIL is not the only way, but if you want to do FOIL, we do that. Minus square root of 2 squared. Fact, oh wait, no square. We expand this. So that's square root of 3 minus square root of 2. All right. And then we distribute this time this. That's square root of 9. Square root of 3 times square root of 3 is square root of 9. So that means it's 3. Square root of 3 times square root of 2. That's negative square root of 2. So that's negative square root of 6. Negative square root of 2 times negative square root of 2 times 6. Oh my God, sorry. Negative square root of 2 times 3 is negative square root of 6. Negative square root of 2 times negative square root of 2 is positive square root of 4. That's plus 2. 3 plus 2, 5, minus 1, negative 1 square root of 6. Negative 1 square root of 6, that's negative 2 square root of 6, and that is your answer. Try this. Multiply these two. That equals 48. We multiply outsides together and insides together and keep them at their place. 6 times 8 is 48 on the outside. X times x is x squared on the inside. We multiply these two. 4 has no radical, so that means it's going to be on the outside, multiplied by 6. So that is plus 24, the square root of x. These two multiply, so that's negative, because one is positive, one is negative. 64, 8 times 8 is 64. Square root of x. And last, negative 32. Let's combine our terms and simplify. 48 x square root of x is f squared, is x exponent 2 over 2 is x. Knowing that x is positive, they said it here. So x, and then plus 24 square root of x. Can combine them, right? We can. 24 minus 64 is negative 40. Square root of x. And then we have negative 32. Then the last thing is to simplify these things to have the most simplified expression. To get that equals, oh, that's it. That's it. We have nothing else to do on that. 48x squared minus 40x minus 40 square root of x minus 32. And then that we will need to do the same as we did here, right? So that's going to be the square root of 7 plus x times the square root of 7 plus x equals, do this. Square root of 7 times square root of 7 is square root of 49. So that is 7. Square root of 7 times x is plus x square root of 7. I am waiting for you that are going to say, oh, that is square root of 7x. If you say that, and these are the signs that I'm gonna have when you don't watch my videos. If you don't watch my videos that I spend time to make for you to study for your test, I have excuses. Okay? When you don't pass my tests, because I spend time doing this for you to take advantage of it. And then we do this again. That's another plus x square root of 7. And then we do this plus x squared. Then we continue with that over here. 7 plus, let me put it in order. You know what? Yeah. The x squared first. X squared. And then these two combine to 1x squared root of 7 plus another x squared root of 7 makes it 2x square root of 7 and then plus 7. So that's your answer here. Welcome to your answer. You see how the x is outside? Please don't put it inside, because if you put it inside, I have no room to give you any credit because you don't show any proof of understanding of this material. Rationalize. Rationalize means remove radical from denominator. That's what rationalize means. And you can see throughout the problems that we were doing, whenever you multiply square root of something times the square root of the same thing, it cancels the radical. It gives you the thing. So for you to remove radicals, you need to understand that all you need to do, wherever they want you to remove this radical from, you always have to multiply by the same thing here. And that makes your life very easy, because this will give me 5, no radical in the denominator. In the top, you multiply outsides together and inside together. That's your answer. Welcome to your answer. Whenever it says using I notation, then you can go ahead and solve your radical with the index even and the radicand negative. But if it doesn't say it, all I'm expecting from you is to say not a real number. If it says solve it using the I notation as needed, that means they expect you to transform your number that is not a real number to a complex in order to solve it. In this case, we can do that. So that is the square root of -1 times the square root of 28. This is I. So that equals I square root of 28 is 4 times 7. Square root of 4 is 2. So my answer is 2I square root of 7. 2 times I, 2I, and then the square root of 7. Okay, almost done. Almost there. How do we add complex numbers? If you know how to combine like terms, you know how to add complex numbers. Let's see this. That is, there's no constraint for you not to drop your parentheses. Let's do that because they're embarrassing. They don't help at all. So 4 minus 4I plus 4 plus 3I. See, nothing changes. The only thing that changes is that these parentheses that we don't even need, I just remove them. Combine like terms, 4 plus 4 is 8. And then -4I plus 3I is -I. negative 1i. So negative I. That's it. Next, subtract. So for this one here, it's like you have a negative one here that will distribute over these, changes the signs. The first one is okay, 7 plus 5i. But the second one, negative 8 plus 8i, changes the signs because of the negative sign on the outside. So that combined like terms, 7 minus 8, negative 1, plus 5i plus 8i plus 13i. That's it. Next, distribute this 3i over everything inside would mean 24i when we get 3i times 8. And then minus 21i squared because we multiply 3i and 7i, negative 7i. It stays negative. 3 times 7, 21. I times I is I squared. We will never forget that I squared is negative 1. So that gives me 24i minus 21 times negative 1. Negative 1 times negative 1 times negative 21 is positive 1. So 21, this plus 24i is my answer. Over here, we can FOIL. 3 times 7, 21. 3 times I plus 3i. 7i times 7 plus 49i. And then 7i times I negative, plus 7i squared. Then we have 21 plus 3 plus 49 is 52i. The I stays. And then plus, well, actually it's negative because negative 7i squared is negative 7. You have to remember that. Negative 7. Combine these two gets me to 21 minus 7. 21 minus 7 is 18. Wait, what? 21 minus 7 can't be 18. It's 14. 14 plus 52i. 14 plus 52i. And then here we multiply. Do not multiply elements that are not in the same place. If they are inside of the radical, multiply them together, keep them inside. If they are outside, multiply them together, keep them outside. Remember that, right? So that is 3 and 7 are all inside and outside is 1. So that's square root of 21. And then same thing here, plus square root of 15. And that is it, because we can't do anything more. Rationalize. Separate the radical, square root of 16 over square root of x. Square root of 16, we know it, it's 4. Square root of x, we don't know. But we want to make it rational. So we multiply by square root of x on top and on the bottom. We cannot do it on one of them. You do it on both top and bottom. And then that gives me 4 square root of x over square root of x times square root of x is square root of x squared, and then it's x over x exponent 2 over 2 equals x. So that is x. That is your answer. And that is it for the review. You have all, for all the 35 questions that I solved for you, there will be no problem on the test that is one of the example is not solved on this test. Please watch this video. Watch it again. Watch it again. Rewatch it. Make sure you master every single thing on this. And then go back, do your test 2 practice problem for the 10%. And then I don't see why you would not pass this test. Good job and good luck. I'll see you on the other side.